So the RL load connected in series with the circuit. You can observe that this is the CRO to measure the voltage of current waveform. So what you have done here, you can observe here, they are connected in just, so this is the voltage and current sensor. So these two terminals connected parallel with the load, then the current sensor, these two terminals connected in series with the load and ammeter here. Okay. The output whatever coming from the voltage current sensor connected to the CRO probes. You can observe here, CRO probes are taken here. So see how they are connected. So CRO probes is connected, one is series and parallel. You can observe here, series and parallel. So these two are connected to here, one and one. Okay. The output of the voltage sensor connected to the one, that is one probe, and the output of current connected to one probe. Okay. So to measure the voltage waveform and current waveform. Now this is the pulse generator. So you have to put the pulse to the SCR 1 and 2 in order to on the SCR. So where you are giving the pulse at the gate circuit, you can observe the gate circuit. And also see that the red point, so red and black, you can observe the terminals. These terminals must be red and black. It must be same. You cannot continue in opposite direction. Okay. Similarly, you can observe here these two in red and black. Similarly, red and black. Okay. Same are connected. Okay. Now switch on the pulse. That is the pulse kit. This already is switch on. So now we can, it is 180 degrees. So 180 degrees means it is a 0 or 180 degrees. You do not get any waveform. You do not get any reading also. You can have the 0 reading. Both are 0. And also waveform also there is no waveform. Now I can decrease. Take up to 160, 150 or 150. So now the firing angle is 150 degrees. So you can see the current, how much of voltage you are getting here, nearly 6 volts here. So the current is 0.01. Okay. So here now you can observe the waveform here. You can observe the waveform only off, that is the only positive you are getting. Positive you are getting here. You can observe here only positive. So this is the voltage waveform, the current waveform. Because you can get RL, that is resistance and inductance, that's why you will get the small negative waveform also in the downside. You can observe here. So this is the voltage, current. Okay. Now I will take another firing angle now. Now I will take 120 degrees. So 120 degrees. So for this 120 degrees, how much voltage you got here? So nearly it is 24. So 24 here the scaling is 150. So 300 take into 2. Okay. 150. Okay. So this only content only 150. So take the same value. So this is 150. So here you got 24. Take 24. Now here the current is exactly 0.05. 0.05. So this, you can observe the waveform now. Now angle is 120 degrees. So you can get the clear. You can observe here. So the voltage waveform. You can observe here only positive cycle you will get. The negative cycle is disappear here. 0. Disappear. Okay. This is the current waveform. Okay. This downside you got, that is a extension of, that is extension angle. So this is the, because it is a RL circuit you will get here. If you take only R circuit, you will get the pure, that you will get like a voltage, you will get the same current also. Because you are taking RL load, so current waveform is different from the voltage waveform. You will get the, that is the negative side also, there is small extension. Okay. Then I will take next firing angle 90 degrees. Yeah, 90 degrees. Now you can see the voltage nearly it is 52 and current is 0.13. 0.13. You can see observe the waveform here, you will get the clear. You can see the waveform, voltage waveform and current waveform. Okay. Then take next firing angle 60 degrees. Yeah, 60. You can observe the voltage now increase. So it is nearly 76 or 77. Now the current is 0.2. 0.2. Now we can observe the waveform. Now clearly you can observe the waveform. Okay, so voltage, current waveform. Okay. Now next 30 degrees I will take now. The firing angle now we are taking 30 degrees. Yeah, 30 degrees. Now you can see the voltage now 95. Current is 0.25. Now you can see the full, we can see, observe the, we can get full positive half cycle, only positive half cycle. The current also can see the positive. Okay. 0. Now we will take 0. Now we are decreasing to 0. Yeah. Now 0 means we will get the full value. So nearly it is 105. So here you will get the 0.28 or 27. Now you can observe the full waveform here.
Stop it, sir. అది పైన నల్లది అదిగా సార్ అది కొట్టు
సరే auto save. Now see the waveform, voltage waveform, current waveform. So because 0 degrees means so directly the voltage whatever the given supply you get here. You are given how much voltage? 115 volts here. This is the same voltage. This is a small drop. So voltage waveform, current waveform. So this is now the working of a off control rectifier.
అసలు కంటిన్యూ అవుతుంది.
Okay. Now you can see this is the waveform for RL load. So you can sinusoidal. You can observe here firing angle pi. If you take alpha, this is a pi plus alpha. So for pi, that is we will get the half waveform. You can observe only half waveform, not getting the full waveform. Similarly, current also, because this is R load. In R load, the current one voltage are in phase. So that's why you can observe the waveform, the voltage and current are both are same here. Okay. So this alpha you are taking for coming to sample calculation. So alpha equal 30. So when you column with 30, so your supply voltage is RMS voltage, but here you are getting in formula VM, that is the maximum voltage. So you have to take the into root 2. So 115 into root 2. So there is a 96.6 you will get. Similarly to take the RL load. So RL load will same value. So 115 into 2, 1 plus cos alpha. Okay. Now coming to the waveform, you can observe here. So this input sinusoidal waveform. There are two firing angles. You can observe the voltage here. But the current waveform is different from the voltage waveform because the RL circuit. So RL load, that is the inductor will store some. It takes some time to allow the current. Then it store the current. You can observe there is a small change in comparing to the R load and RL load. So this is the difference. So this is the that is load, R load and the RL load. This is the sample calculations. Now coming to the readings. So I am taking the readings here. Just to this for R load. Just to by seeing this video. Just to you write down the table, that is you write down the same readings in your record. So already you are seen for alpha 30 degrees how much you got? 96.6. So here we can observe theoretical and practical. So theoretical you got 96.6. So already you can observe here. So you get 96.6 here. Okay. So these are practical. So theoretical, practical. Okay. So these are voltage, current. Similarly voltage, current. Okay. Just you see that this by doing this, take the readings and you copy down your record. Okay, thank you.